Hello and welcome to today's streaming media webinar. I'm Eric Schumacher Rasmussen. I am the editor and VP of Streaming Media Magazine, and I'm also the program chair for our Streaming Media West conferences. And I'd like to welcome you to our discussion of cloud versus on-site production, looking at the differences, advantages, and opportunities presented by LiveU. And we'll be joined in just a moment by Dan Pisarski and Janel Fleming from LiveU. Before I introduce them, though, just a few program notes. We will have a Q&A session at the end of the webinar. We request that you put your questions in the Q&A tab at the bottom of your screen rather than putting them in the chat. The chat will be open and we'll leave it there so folks can say hello and discuss what they want to discuss, but we do ask that you put all of your questions in the Q&A. That makes it easier for us to keep track of them and make sure that all of your questions get answered if we have time. Occasionally we do run out of time. And so if we do run out of time before we get to your question, we will make sure that our speakers get your question and they can answer it offline after the webinar. Also, the webinar will be archived within 24 hours for on-demand viewing. And just for participating in today's event, you are registered and entered to win a $100 Amazon gift card. We'll be announcing the winner on September 30th, and the winner, of course, will be notified via email. So with that, I would like to introduce both of our speakers, Dan Pisarski and Janel Fleming from LiveU. Welcome.
Thanks, Eric.
How's everyone doing today?
Doing well.
Great.
Good, good. I think we thought we were going to be doing a few less of these virtual events, but as we've discovered this week with both NAB and Streaming Media West canceling, in Streaming Media West's case, we're going virtual. We're going to be doing a lot more of these. And so it at least gives us a chance to keep the conversation going. And,
Agreed.
And certainly one of the biggest conversations in the last 18 months has been about remote production in general, as I think everyone has said that, you know, we've seen about 5 years worth of advances in remote production in the last 18 months. And you're going to talk about one specific aspect of that, which is production in the cloud versus production on site. So I'm really looking forward to hearing what you have to say. And with that, I will pass it over to you.
Thank you very much. So hi, everybody. My name is Dan Pisarski. I'm the VP of Engineering for the Americas for LiveU. And I'll let Janel introduce herself as well. Oh, wait, she went away.
Yes. Hi. Sorry. Janel Fleming. I'm the Director of Sales and Sales Group Manager for the Sports Division in the U.S. here at LiveU.
So today, what we wanted to talk to you about was just some perspective that we have on the cloud production so far. And what I really hope to do is kind of maybe expand your ideas a little bit about what cloud production really means and what you can do with it, to kind of see some more options that we see when it comes to cloud production. That's really kind of the overall theme of the presentation. So, you know, just a very quick recap of kind of what got us here. I think, you know, probably everybody here is pretty familiar with what we mean by production. Like in the beginning, you were usually literally in the same building. You know, you had a studio in one room and the control room in another room, sometimes even with a pane of glass, not just monitors in between you, you know, to look into the studio, and production was done right there. But since then, you know, production has evolved. Instead of having to all be in the same spot, what we see, you know, today, or what we've seen over the years, is an expansion to obviously make that more agile and mobile. So going way back, you know, decades ago, we made that shift to let's load all this gear inside a big truck, sometimes literally, you know, an 18-wheeler kind of monster truck, and bring it on site and do the production there. But that still involves, you know, running the cables literally from inside the venue, whether that's an arena or a building or concert hall or whatever it is, out to the trucks, you know, parked on the street. And we've probably all, at least once in our lives, walked past a truck with a big bundle of cables running out, you know, across the sidewalk, and caution tape around it to hit the truck outside. More recently, in the last decade, 6 years or so, this switch to REMI, remote integration, kind of a weird acronym for it, not quite a true acronym, where now we can be much more agile and just bring the cameras on site and transmission gear and leave kind of what you see in the top picture here in some sort of central location and backhaul the video from wherever the location is to that central location to the production there. If the backhaul is fixed latency between the two, and hopefully fairly low latency because that helps with kind of real-time communication, then it's just the same as if you're in the other room. I mean, video is still being transported somehow and arriving to you, and the difference of you might not even know that if you open the door, you're not looking at right at the venue where the production is taking place. And of course, where somebody like LiveU has contributed and fits in this equation is with technologies like bonded cellular, which is the idea of bring your own bandwidth to where you're going. So instead of showing up at the venue with your camera crews and hoping to be able to transmit those cameras back to your central location in your REMI model, now you're showing up with a camera in your LiveU pack, and you know that you can transmit it back. You don't have to worry about what kind of bandwidth the venue has and where the land drops are, and if the Wi-Fi is really private enough or strong enough to to get you on. So it's a bring your own bandwidth equation. And then most recently, and certainly driven by events in the world in the last 18 months, the global pandemic, cloud production, which was there beforehand, and I think a technology that everybody was interested in, but I don't think we can deny that we all raced much faster towards it, given what happened in the world, than the pace we were going at before in terms of exploring that technology. So what I kind of mentioned in the beginning, my goal is to sort of expand what you think of when it gets to that last term, cloud production. And what I mean by that is when I say production, I kind of guess that many of you, maybe not all of you, many of you, still think of the big production switcher, the true full vision mixer, audio mixing production that takes place to take something, live event happening and turn that into a program with many different camera angles and the ability to bring up graphics and ability to cut to commercial, as part of that program. And that certainly is, you can do in the cloud, and there are increasing systems that let you do what these big devices, hardware devices, would have traditionally let you do entirely in the cloud. And there is certainly a lot of use cases for that and excitement around that. But what I want to now present is that that's not the only thing you can get done with the cloud. You could be doing a REMI production, even really an on-site production, to be honest, using one of those big expensive switchers, often expensive switchers, and getting the production done, and still have an interest in doing some other workflows. And maybe that's a place where the cloud can fit and can enable you to do that workflow without necessarily having to bolt more gear into the rack. So, the examples that I have there would be taking that same content and repurposing it for a whole nother platform, like a betting platform instead of the primary production output, or to a social platform, which, is certainly nothing new. We've been taking content to social for decades now, or for a decade now. You can localize it. Something that this is use case we've heard some really exciting stories about recently, where interest in whatever you're producing, sports is a great example. You suddenly find another country that has a high interest in that same content, and that's another market you can bring that content to, but you've got to change some audio graphics, add a voiceover, add some subtitles to it before the content lands there, and that's something you want to do. Second screen experiences, which maybe aren't as exciting as they were a few years ago, but they're still out there and kicking, and people are still interested in producing content for it and taking the content you're already producing and using it there. And then, of course, just translation of that content for other devices, right? Like increasingly trying to tailor content to be able to hold the phone vertically instead of having to turn it horizontally and watch it. So these are just a few of the examples, and I'm sure you can think of more of things that maybe you're not doing today that you're excited to do, or that you're doing today and finding a little painful because it requires more staff, more gear. You can't have all of that staff all in the same room anymore, and we want to all move away from the world where we have to capitalize new equipment, bolt it into a rack, use it just for that one purpose, and 5 years from now replace it. So what drives that interest in all these different ways to use that content, all the things I just had on the slide before, more chance to monetize that. So you've got the core part, the production itself, which is, you know, probably a good expense for you and for everybody involved, and then the chance to take that production that you're doing and monetize it again and again with just some modifications to it, rather than having to do a whole second or third production to create more money there. And that's, you know, not telling anything new here. I think we're all aware of these trends of, you know, the slow decline of traditional TV advertising and the increase of online advertising. I think for everybody, the idea that I can take this content, produce it once, and use it in many different contexts, many different locations, many different ways on many different devices, and monetize each one of those potential outputs is very exciting for everybody who's in the content production world. The other way I want to try to expand your mind in terms of where the cloud might fit to help you with your production is to think that all the things these days that we lump under this umbrella of production doesn't just refer to vision and audio mixing anymore, right? I mean, certainly you've got graphic overlays, you know, file-based playout, slates, you know, heads and tails that you're putting on are all part of the production. But increasingly, you've got things like accessibility, the addition of captioning or a voice description track, you know, clipping so that you're getting highlights to social media as fast as you can. Control, you know, as actual part of the production, things like control of robotics, PTZ cameras, lighting up tally lights, communicating with everybody in, you know, in the field that is doing part of the production. And then of course, all of the prepping it for the destination, which maybe is not quite production, we would call that distribution, but, you know, sometimes falls into the responsibility, especially if you're responsible for the full chain of figuring out how that's going to be done. Output transcoding, packaging, packetization, streaming, you know, all those components. So you might be doing some of this already in a REMI model. You might be doing some of this already on site. There may be things that you feel like it's painful for you to do, or things you're not doing today that you want to add, like accessibility. And those could be things that you add through the cloud and not necessarily have to do through the addition of more gear on site. Not saying, you know, the ones I've highlighted here are the ones you should add through the cloud, just a hypothetical example, but you can pick and choose out of the full list of what you're going to add in the cloud. But let's dive a little bit into technically exactly how you do that. I think it's, you know, it'll help you understand kind of the options in front of you, and we'll highlight one specific point I want to make about the trend right at the moment when it comes to what we think of as cloud workflow or cloud productions. And not that that trend's not going to change fast. I mean, this is obviously all technology that changes and moves very quickly. But there's kind of three basic models, and these are really my terms. I'm not saying these are necessarily industry standard out there for how software that was once used locally gets to the cloud, or how software is written from day one to be ready as a cloud production video interactive software. The first one, called forklift, you might have heard that term before, is really, I happen to have a piece of software, probably one that was meant to run on a laptop, right? And interact with video there through direct plugins to that laptop, USB and, you know, USB-C, back in the day, FireWire and things like that, that I just happen to be able to run in the cloud on a Windows instance in the cloud that also has a GPU available to it. And thanks to technologies like very, very low latency remote desktop, I'm able to just see that Windows desktop as if it was kind of right in front of me on a laptop and use that in the cloud. That's still cloud software, and I'm not passing any judgment on, you know, how that software got there. But it's important to understand that kind of setup because it changes the architecture you need. It changes the cloud resources you need in order to run that. Then you've got kind of, and this is maybe the most common today, a hybrid model of that, where the software was written for the cloud or has been modified for the cloud, so that you're not just literally running a remote desktop instance of Windows to see that software's user interface. However, you do end up with a dedicated cloud resource during the actual production, and you're the only one on that resource. So you've probably, if you've worked with some other cloud platforms and cloud software today, this will look familiar to you. It's the kind of platform where before the production begins, you need to come and click start somewhere which actually starts some engine in the cloud for you. And then that's your resource that you use during the production. And that's usually when your billing starts as well. You might be able to go in and set up metadata and settings and configuration, for the production beforehand, or for whatever part of the workflow you're going to do. But once you actually click start, the money counter starts as well. And that's what the bill in the end. And then you click stop at the end of the production. So that's, I would refer to as like a partial forklift. There's probably better terms for it as well. The last one, a little bit more, from other parts of the software development world, when they think of cloud and true cloud scalability, what they think of as cloud elastic scalability is what we mean by the last one. And it's a little less common for video because it's very hard to do with video, right? A true elastic scale. And this is where I'm able to just send video at this sort of ethereal thing in the cloud, and it figures out where to route that and what to do with it. I don't need to hit start and wait for an engine to fire up for me and then use that engine. I just send video at it. It does the transformations to it. It outputs the video wherever I want. And under the hood is all sorts of software magic to figure out, okay, I've got this many available GPUs somewhere in the world. I'm going to, send frames of video through those GPUs. I'm going to recalibrate them back into true video on the far side, and re-encode them and send them back out. That's true elastic scalability, but again, tricky to do with video, which is high data, linear information, in sequence of frames and audio. It's a lot easier to do with like web requests all coming into a text-based website that do this kind of elastic scaling. So again, I highlight these three different architectures because they make a difference to your plans. If you're thinking of some of the use cases I outlined in the beginning, or some of the components of production I outlined in the beginning, and you're thinking, yeah, it does sound good. I could do, I would love to add accessibility to my videos. Let me explore doing that in the cloud. You probably have sort of this architecture in mind, or maybe another way to state it is this architecture would have kind of been the ideal architecture for all of us in mind to get it done, which is I'm going to send the unit from the field over your LiveU, of course, I'm sure that's what you're using. And that's going to hit some cloud service, which is going to do some transformation on it, add graphics to it, add captioning to it, reformat it for different screen types, whatever that's going to do. And then maybe that's not the end of my production. I also need to send it on to a next step, which is going to just accept that video from my first cloud vendor. Think of it like a best of breed approach, and do more to it, transcode it so that it's ready for cell phones around the world, and repackage it into HLS so that gets delivered to the phones. And then at some final step, it's going to go to its true distribution, which is usually like a CDN or OTT. In the last 18 months, it's also been come back to your actual MCR head-in and go back into a more traditional TV workflow if that's the kind of production you're doing. And this would have, been a great architecture where everything kind of would have flowed together, and I could use a best of breed approach in terms of the tools that I want to use, and I could do multiple transformations to the content before it's sent out to its final destination. What got in the, I think you can guess, from the way I'm presenting this, that something got in the way here, and let's talk about what got in the way. I think it's very understandable to all of us that the yellow arrows here need to be high resiliency connections, and just based on the way resiliency works, high resiliency typically means higher latency as well. So the connection from the field to the cloud being somewhat higher latency, perfectly acceptable to us. The connection from the final distribution to the end user's device, them literally watching it on their TV or their phone, having somewhat higher latency, completely acceptable. But what our expectation really is that the interconnects in between these different SaaS platforms or cloud software would be pretty low latency and pretty high quality, so that we're not ending up with a stacked total latency that's just unacceptable in terms of the workflow. And the problem is that when you route video between different cloud services, if those services are hosted in different public clouds, one's hosted in AWS, one's hosted in Azure, it needs to be high resiliency. Even if they're hosted in the same public cloud, if they're routing between two different virtual networks in that public cloud, they need to be high resiliency. And so then that adds latency at the green arrow you see here as well, and has a quality decision you have to make at the green arrow to keep it low bandwidth. And that becomes an issue for this workflow as outlined. So what we've, and just to dig into that for a second, a term, dig into some technical terms here. The green arrow in this example before ends up being compressed domain, where in your on-site workflow in the pre-cloud days, that was uncompressed domain. It was probably SDI interconnecting different things, your mixer to your audio mixer to your output encoder, things like that. What's the difference between compressed and uncompressed domain? Uncompressed domain is pretty easy to understand. Like I said, we've all used it for decades. It's called SDI, right? That just happens to be over a coax cable instead of packet network. But we all get the idea. It's uncompressed video at extremely low latency. I just plug in the cable and it works most of the time. And it's a great way to interconnect devices, but it's got a shortcoming in that the cables can only be of a certain length, and it doesn't, route over my typical IP network like my WAN or over the internet. Compressed domain, which we're all also familiar with, even if you're not down in the technical details, because you've all watched YouTube at some point in your life, is highly compressed, usually highly resilient IP-based streaming, so that the video arrives to you regardless of the conditions of the internet in between you and wherever it's coming from. That's directly related to it being highly compressed, because the lower the bandwidth we send, the more chances it's going to arrive to where it's going. So it's not that one's necessarily better than the other. It's just that with compressed domain, you certainly have an implication of resiliency takes more latency, compression and decompression takes more latency, and that compression and decompression has an implication of quality. So anytime we use something that's compressed domain, we've got to make a decision of how much quality are we willing to give up in order to meet the bandwidth that we're trying to hit. And we've got a decision to make of how much latency are we willing to accept there based on the resiliency that we need. So the green arrows ending up being compressed domain kind of becomes an issue for these workflows working great. So there has emerged a solution to this. And again, I'm not saying that this solution will go on forever as the technology continues to progress, but for the moment, protocols like NDI, and really NDI itself, I mean, it kind of stands alone for just this moment, has worked great as a cloud interconnect format. While it is compressed, it's a form of lossless compression that has very high quality, extremely low latency in the one frame kind of realm, behaves very much like SDI in the way it interconnects, but can run in the cloud over pure IP in a virtual environment. So we really see NDI as having emerged as a favored interconnect. Other protocols are also used. So some cloud tools will now interconnect over SRT. There's still a ton of RTMP used all over the world and will be for a long time. But those compressed domain protocols always carry this implication of, even if you kind of turn all the knobs to the best possible settings that you can get, you're still talking about hundreds of milliseconds of latency, or a little less, but tens of milliseconds of latency. You're still sending compressed domain video, which is has implication of quality. Where with NDI, you can send less than one frame and very high quality video in between the two. Now, I keep mentioning until the technology progresses further. We see some emergent protocols, specifically Amazon CDI, as beginning to emerge to give NDI some competition and take over. How could we interconnect different services in the cloud, keep video at very high quality, very low latency, and not necessarily have the one shortcoming, which I'm about to outline, of NDI. But it's, Amazon CDI is still very new, very few services support it yet. We'll have to see how that technology develops over the next few months. So now you think to yourself, okay, great, I'll just use NDI as the interconnect. What's the downside? This is the solution, right? There's only one downside to it, which is NDI is not routable over the public internet, or even in between different virtual LANs inside the same cloud host. Yet it's the newer versions of NDI have some options of compressed domain video or TCP delivery for further routing, but those really kind of just move it back into being a compressed domain protocol. So the form of NDI we really mean here, the very low latency, very high quality protocol, has to be in the same what's called a VPC or virtual private cloud, really meaning your virtual LAN in the cloud. So it's got to either be all the components that now you want to route video in between as part of your cloud workflow. If it's not one vendor doing everything that you need in kind of one application, need to all be hosted in the same virtual private cloud. That could be in the vendor's virtual private cloud, although it's overall fairly rare to find one vendor who will host another vendor's components in their cloud. And so usually again, right at the moment, it ends up being your cloud, right? You set up a VPC in one of the public clouds like AWS or Azure, and then everybody gives, all the vendors like us give you a component to run in there. And that component does the job that you're looking for in terms of your cloud workflow. You interconnect them over NDI, gives you all the advantages I just outlined of NDI being the interconnect. But it puts a little more burden back on you, the end user, right? Knowing how to set up a VPC in the cloud, getting the bill from the public clouds in terms of the resources used, having to configure all the security settings and ports, networking that go along with it. So it's a little bit of a hybrid world right at the moment, where that feels a little bit like having to get some of that gear and bolt it in a rack and plug in the cables yourself, but it's all, clicks with your mouse, settings on the cloud side, and it still has a lot of the advantages that come along with cloud. I can set it up and tear it down once I have all the things I need very quickly. I can scale, to a kind of burst of need. So if I've got 1 week of a ton of production, like elections or the Olympics or something like that, I can, scale up to a huge capacity just for that time that I need, and then scale back down when I don't need. I'm only making an investment in the cloud resources I use at that moment, not a capital investment in gear that's going to sit there for 5 years and depreciate. So it's still got all those advantages, just comes along with not quite all the upside as if we could do that first workflow, that we had first looked at. So now, the interconnect is NDI. So where do we fit in all this? We're on both the contribution and distribution side. And based on everything we've just shared here and kind of observing this over the last 18 months, we've tried to prepare solutions for each one of those possible workflows. So you can use our contribution encoders to, of course, go live to a physical server still in some sort of facility somewhere, or to a cloud server, or both at the same time. And that cloud server can be hosted by us if you're going to use any kind of compressed domain high resiliency protocol to route onto the next part of your cloud workflow. We've supported RTMP, really almost since LiveU began. Just recently launched SRT and joined the SRT Alliance. So now SRT is an option to interconnect that. But we've also long supported NDI since it was first introduced a few years ago. And you can run that now in your own VPC on our software that will give you to run in your VPC and output NDI from that and make that part of your cloud workflow as well. So that lets you kind of build a whole, workflow chain where you're using LiveU, everything from multi-camera input, HD up to 4K, or from your smart device to ingest in the cloud, and then get that back out as the next step in the workflow that you're interested in, RTMP, SRT, NDI. Do any one of those extra workflows I outlined in the beginning on it, from full production to still do your full production on site, but in the cloud do content repurposing for another country, localization, repurposing for a different kind of platform, interactive platform or betting platform or whatever it might be. Just go to social with it. And then if you still need distribution from there, pick up, come out of the cloud workflow you're using right back into LiveU Matrix for our distribution side, if that's what you happen to be using. So from there, I'll turn it over to Janel to talk about, wait, I almost forgot one more slide. So we just recently have made a few announcements of different cloud platforms we worked with, because again, we definitely see the advantage of getting not just the one sense of production done, but getting many different possible cloud workflows done. And we know that you're going to want to route video from your LiveU workflow onto many different vendors to get that done. We started doing some testing with different vendors, making sure we'd ironed out any issues, added some features to make that integration better, and then ended up working with some specific early adopters to make sure that the whole thing went off without a hitch. So based on that, we've kind of announced these recent partnerships. Just, a small sample. Obviously, video coming from your LiveU would work with a long list of other cloud software vendors out there, but these are ones that we've had a chance to work very closely with recently with great success. So I'll let Janel dig into a couple examples of that in the next couple slides.
Thanks, Dan. Yeah, so I mean, we had a couple really great successful use cases of producing live content in the cloud, and one of our partners, Grass Valley, launched the AMP platform, which Dan described a little bit. It's virtualized switching, audio mixing. You can see your multi-viewer, everything that really traditionally would be done on a hardware-based switcher and hardware-based control room can now be done in sort of a turnkey solution in the cloud. And when this is enabled, the personnel controlling it can really be located anywhere. So this is one of these examples that a sports event, they used a multitude of LiveU units to backhaul, I think about 8 cameras into the virtual control room that AMP hosts. And we had our cloud server installed in there. It was hosted in the VPN, and SRT out into the environment, and the director, producer, graphics operators, even the audio mixers were all located remotely producing the event. So the incredibly successful and interesting application. They even implemented the ability to do camera control remotely in the cloud. So it's just the fact that a sports event is being done this way today, I think is interesting. The next slide is sort of Dan touched on it, but we also have a platform called LiveU Matrix, which is a content sharing platform. Sort of the idea of it was a lot of broadcasters have LiveU units they use for ENG purposes, and they have news sharing agreements as well with other broadcasters. So rather than send reporters and 16 cameras to site, you can sort of outfit your unit to be shared and dynamically grabbed on an ad hoc basis by other broadcasters who have the LiveU infrastructure. So in Germany, we had the elections, and they took it one step further. So CDC, one of our longtime customers, actually have 12 or so LiveU units down the field covering the election. There was 12 party venues they had outfitted with, and so they made all their feeds available into the Matrix for the other news channels to grab live. But they also had a partnership with Blackbird, one of our partners, where they actually recorded all of them for live clipping and editing for the editors, who obviously this was a COVID situation, so people were living at home. So the editors were actually able to do collaboratively, edit, clip, all the things that they normally do in a control room completely remotely. And it could all be shared across the multiple news channels. So this is just one of those sort of, they're still doing live into their broadcasting, but they're also publishing highlights of the events. They're doing stuff for their digital channels, everything in real time, as it's happening, completely in the cloud. So, and this could be done really with, and we're starting to talk to, sports teams doing this, where, they're not able to send bodies to an away game where they would normally go and do set up shop and plug into internet and do their, getting an SD card delivered to them so they can go and put stuff on social media. Now it can be really done in the cloud, and it's growing the efficiency and the end product to the fan, right? They get to see stuff when it matters, right when it's happening. So that's about it on the presentation side. I think we got some questions probably, Eric.
We certainly do. Thanks so much. Yes, and if you do have questions for Dan and Janel, you can continue to put them in the Q&A tab at the bottom of your screen. The first question is kind of a big picture question, and it goes a little beyond the specific scope of cloud production, but are outside broadcast vans on their way out? and how much does 4K, for instance, and 4K HDR influence the ability of broadcasters and other video publishers to work without broadcast trucks if that 4K HDR quality is required?
You want to take a shot at that one, Janelle, or you want me to?
Yeah, you go for it.
So we right today the LiveU units actually are capable of 4K HDR transmission. So I do agree that like even if the sense was, boy, we still need the OB van because we're going to do 4K HDR and things like bonded cellular just aren't quite there yet for that type of transmission. That is, now starting to fade. So the LU 800 has that capability. We have that in use in the field. You've got technologies like 5G and even really the later versions of LTE, like LTE Advanced, Category 18 and stuff that are capable of a lot of bandwidth through the air. Starting to have emergent some ways to even start to guarantee that bandwidth. So things like LTE prioritization that we saw, launched in the US in the last year, as well as like the forthcoming 5G slicing, network slicing. It really, I say we're in a transitionary period now. I mean, there's still some great OB vans out there with a lot of great gear in them and being, used well, but I think that time is only going to make that diminish even more. All of that's is now capable of being transmitted over bonded cellular, and you don't need the big OB van anymore.
And I would add, top live sports, a lot of it may not change, right? There's still, sort of a split, I think, in the mentality of, is Remy really better? And I think in the tier 2, tier 3 sort of digital channels, I think that's really where you're going to see a quicker adoption of not the OB van going away, but it changing the on-site infrastructure being more of a sprinter van with a CCU and maybe some audio mixing and camera operators. But yeah, it will certainly, I think, shift faster in that market. And we see it today already.
We have a bunch of questions here that focus on LiveU products specifically. It's almost like people are saying, hey, we can't visit you at NAB, so let's take this opportunity to ask you all the questions that we would have asked you in Vegas. But I have another question in the chat that's a bit broader. What about JPEG XS? Do you see it replacing NDI as more products supported for customers demanding higher quality and lower latency?
I like JPEG XS. I think it's a very interesting technology. I think that when they, and this is only my own opinion. I mean, classic, what you like the Twitter opening of like, these don't even necessarily reflect the opinion of my company. When they first made SMPTE 2110, the focus was on like, we're going to stick with uncompressed as like generation 1. And that was, they couldn't have anticipated the coming global pandemic, but it kind of turns out to be sort of a big miss on their side, because the uncompressed bit rate needed is still a blocker when it comes to cloud workflows. Even when we look at something like Amazon CDI, which is effectively 2110 under the hood, the fact that you need 10 gigabit, 12 gigabit, or 25 gigabit between the different instances limits the type of instance you can use with Amazon CDI, and it makes it very expensive to implement. So, early on, you did have some of the original players that kind of came together and formed what eventually became SMPTE 2110, pushing for, we should have some sort of lossless or near lossless compression in this, so that you're not using 10 gigabits to send this, transmission through. You're using 5 gigabits or 4 gigabits to get, 4K through. And there was technologies like TICO as one of the codecs. And I think, in my mind, JPEG XS kind of fits in that same near lossless, very low latency, domain as a codec. I do think they're going to have to be adopted. Like, we're going to end up with a version of either 2110 or a flavor of NDI or a competitor to NDI that leverages these things and can be used in the cloud, and would give, NDI some competition there in terms of what's the right interconnect and what are the pluses and minuses of different formats. They don't seem to be there yet. Like, I couldn't sit down and implement JPEG XS across many different vendors' products, our own included, yet. And so there needs to be some catch up there. And I think there needs to be some properties to it that make that compelling, whether it's industry acceptance or push from a standards body like SMPTE, to adopt that as the compressed domain. But, long story short, I think a compressed, near lossless compression, but nonetheless compressed version of SMPTE 2110 or similar protocols is coming. It has to. And that will eventually give new tech some run for its money on NDI, which is a good thing. The competition, adds, it leads to innovation, as we all know. So that's just a positive thing. NDI's got a nice lead right now, and new tech's doing a great job of innovating on that and adding the features that I think people want for NDI. So they're going to have to play catch up to that to get there. But yes, I think JPEG XS could be one of those codecs that gets adopted as the option for compressed domain SMPTE 2110.
All right, now we're going to dig into the questions about LiveU specifically from some folks who clearly are LiveU users, including Jeff Keithley, who has written for us and spoken on our panels. Jeff Keithley with Live Sports asks, how about NDI input on the cloud server so we can send a return video feed back to the LU800?
Absolutely, that is on the roadmap. So, and I see Jeff also asked about IFB input, audio only input. We looked at a lot of different, what's the protocols people want us to adopt when it comes to being able to accept ingest in the cloud and then route those things back to things like your 3.5 millimeter jack on the units or back to your HDMI output, connector on the units that's used for video return. And NDI does seem to be emerging as one of the most requested protocols. Like to be honest with you, it'd be even a little bit easier lift on our side technically to implement something like SRT in to get to video return or SIP in to get to the IFB. But we definitely hear what Jeff's hearing too, which is people asking for NDI, and that is on the roadmap. Might launch near the end of this year, might be a little bit into 2022, but definitely coming.
All right, and Jeff actually has an SRT question as well. With SRT being added, will we get the ability to send SRT out of the LU Central like we can with our TMP now?
That's exactly right. So in our 9.x version of the software, which is available today, talk to your support rep to get it installed on your either cloud instance or physical server. Then in LU Central, in the streaming tab output where you would normally configure our TMP, SRT is just one of the options, and you can configure it. This first version is listener mode. If you're familiar with the way SRT works, the platforms that we were looking to integrate with early on, like Grass Valley Amp and like Avid, wanted us to support listener mode first. A lot of more web-like platforms that are looking to replace our TMP are looking for SRT transmit mode, and that'll come in our 9.5 version next. But right now you can configure SRT right in the same tab that Jeff's talking about, just for the moment restricted to listener mode.
All right, I'm going to jump ahead to one of the cloud-specific questions. Is there a larger than 4-channel cloud LU4000 type server so we can convert, for instance, 8 channels into NDI for our VPC? There's no hardware card limit. If we're flipping everything to NDI, there are very little CPU limits in the cloud, also considering how efficient the LU servers are.
So today we would advise you to stand up more than one instance with 4 NDI channels out to all in the same VPC to get up to 8 or 12. That really, I agree with what the asker is implying there in terms of it's just CPU, and you can build, things like EC2 instances up to very large CPUs. For us, it's, there's an implication there of like just even the testing part of it, like what are the different configurations we're using for testing? How much do they reflect all the years of experience we have with different CPUs in the field and physical servers? How much time have we had, running these things in the cloud? So it's not that those things wouldn't work or that there's any specific limits in the software. It's that we feel very confident saying, if you build 3 individual instances here, each with 4 channels, we know that's going to work, right? I think that from an efficiency standpoint, one thing with the public clouds, for better or for worse, is that the pricing on the CPU sizing is often linear, meaning that those 3 instances to do 12 channels cost you the exact same as the big giant CPU instance. Doesn't give you a price break to use the big giant CPU instance and have it all on one resource. Might save you a little bit of simplicity in terms of your management of your own VPC, how many things you have to click start on, stop on, stuff like that. I think over time, we'll test up to bigger examples and more inputs and more outputs. That's always the kind of path that this scalability takes. But for the moment, we would definitely advise like a 4-channel max and stand up individual instances as you need them.
There's actually a follow-up asking, are those multiple servers still going to have all 12 channels in sync?
So when you're talking about sync between different units, so we have the quad input LU 800, and that can keep the 4 streams coming into the 800 in perfect frame sync, since they're all being encoded in the same memory space on the encoder. When you're talking about different units and different output channels like that, they, especially in the version we just released, has even a few further improvements here. They can be in very, very, very close sync, plus minus 1 frame, especially if you've got the source cameras gen locked between the two, or between all the cameras. So, and that doesn't change whether you do 4 instances or 1 instance or 3 instance. And the max inputs we have, on the LU800 side is 4. So you're not, even if you had an output server, virtual server with 12 channels out and 4 separate or 3 separate LU800s feeding that, you would still have that plus minus 1 when it came to the 3 different units on the far side. So there's no real advantage in terms of frame sync to doing it as one big instance versus doing it as different instances.
All right, and Jeff Keithley just posted in the chat, says, I know a guy that can help you test the 12-channel setups. I'm sure he's not the only one here who'd like to help you test that. We've got another question about, and I guess this is specifically about the cellular bonding capability. How do LiveU solutions work in crowded areas in which bandwidth is very limited?
So, I mean, that's something we've done now for 10 years, right? And it's a core focus of the company to make this as resilient as we possibly can. And it kind of relies on all the different things the unit does. It's the culmination of all the different resilience technology we've got built into the unit. So the primary one, of course, is just bonding and being able to use different carriers networks or different IP networks to get there. So if you're using all of the different cell carrier networks coupled with, if you're using Wi-Fi in the venue, coupled with if you happen to have a land drop in the venue, we can bond all those together, use them all at once, and that can help you overcome a crowding scenario. But even if you want to keep it to just cellular, and you're worried that even across 3 now carriers in the US after the Sprint T-Mobile merger is not enough resiliency, we've got a lot of other resiliency built into the unit. So forward error correction, verifications, resends, the ability to adjust the end-to-end latency to give more time for things like resends and verification are all part of the resiliency plan to get that through. And then, of course, you've got the kind of emergent one and the exciting one for a lot of people, which is 5G. So get on the 5G network, especially inside a venue like a stadium or something where you've got a big crowd. And for the moment, and we'll enjoy this for the next year to 2 years maybe, that network's not very crowded because not everybody has a 5G phone and they're not doing everything they can on the 5G phone. And of course, 5G has, of course, just higher capacity, more individual devices in the cell, much higher capacity in terms of the bandwidth through the air, especially on things like millimeter wave, and deterministic latency, lower latency on the network, software-defined networks, different than LTE. So that's a big leap forward too. So everything in the unit is there to help you get that signal out, whether that's because you're in an area that doesn't have great cell coverage, which happens sometimes with things like news coverage, but it is really for years and years, our focus has been, it's because you're in an area that's got great cell coverage and also 80,000 other people in it, right? And we want to get that signal through.
Right, and the follow-up, go ahead, Janelle.
No, I was going to say, we also have, in the US, for example, AT&T has built out their FirstNet network. And when they did that, when they won the Fed bid, they also built out a priority network for people who wanted to, have a little bit of priority in a congested environment. So we offer that in all of our AT&T SIMs, which does help significantly in congested environments because you are getting priority access on that network over the, cell phone users out in the area that are sort of the standard connecting to the LTE network. So a couple little tricks here and there that help.
Right. I had a question. Dan, you mentioned sports betting. You talked a little bit about latency, but I'm wondering if you can talk a little bit more about cloud production in ultra low latency situations like sports betting, like interactivity with auctions. What does it look like right now? Is cloud production able to function and provide the lowest the latency that's needed in those kinds of situations?
I certainly feel like I've seen examples where that's true, right? I mean, we had even 2 years ago, we had some examples of low latency applications where they were transmitting over bonded cellular and then distributing that over the internet over, pretty traditional internet streaming distribution technologies like HLS, which tend to be higher latency. And they were hitting, numbers at from glass to glass of less than 3.5 seconds, and that was a good fit for their use case, 2 years ago. And that wasn't a betting application; that was a fire safety application, as I recall correctly. But so now with kind of recent leaps in that, including on our side, where you've got some options all the way down to 400 milliseconds of latency as the initial bonded cellular transmission step. And then you've got things like low latency HLS on the delivery side and interconnects like NDI for your cloud workflow in the middle. I have seen examples where they're doing glass to glass with cloud production at less than a second, in terms of the latency. So I think that's a good fit for all applications that need low latency.
Terrific. Well, that wraps up well, actually, there's another follow-up regarding the bandwidth redundancy in crowded areas. Can LiveU solutions operate in satellite bandwidth?
Yeah, absolutely. I mean, we've offered our own IP based KA solution for a while, and we see KA. KA was pretty widely adopted by a lot of news organizations looking for additional bandwidth beyond LTE. We certainly, have also watched the excitement around the new LEO networks like Starlink, and we've had units tested on the Starlink network, and they work great over the IP. So, nice thing from our perspective is any IP connection we will try to bond. In the old days being, like a year ago before Starlink, satellite really meant, one of the things we had to watch out for was extreme high latency on that connection. It might provide a dedicated amount, 4 megabits of bandwidth or something like that, but it's at like 1.1 seconds or so of round trip time. And so we have to, in our algorithm, account for that, of like, don't get freaked out by this long round trip latency. Now with things like LEO networks, you've got much lower latency, and that's great. It's a huge advancement in terms of satellite transmission. I think right at the moment, I think we all say the Starlink's fairly focused on consumer applications, and they've just kind of recently announced like where they're going with the B2B direction and how they're kind of outsourcing that to other companies like Google. But there's a few other LEO networks right on their tail, about to be partially launched, and constellations already, partly in the air, that are much more B2B focused. And I think that's where we're starting to see a little bit more options for people like, broadcast, TV, news, sports production have more options there than just the consumer focused Starlink.
All right. Well, that actually does wrap up the questions. Thanks again, Dan and Janel, for a great session. We will be speaking to LiveU again during Streaming Media West Connect. In case you missed the announcement, we have gone virtual with Streaming Media West, and Streaming Media West Connect will be happening November 1st through the 5th. And on November 2nd, there'll be a panel on hybrid and REMI workflows for hybrid events. And LiveU is going to be joining us for that. And I'm guessing it will be one of you that we'll be speaking to then, although one never knows. And LiveU will also be presenting a fireside chat in our innovation hours during that Streaming Media West Connect. So once again, thanks everyone. Thanks to our attendees for all your great questions. That wraps things up. Remember, just for attending today, you've been entered into a chance to win a $100 Amazon gift card, and we will announce the winner on September 30th and send an email. As I mentioned in the chat, the presentation from today will be available as a PDF for attendees, and you'll receive a link to download that when you receive the link that has the archived version of this webinar to watch and share with your colleagues. Thanks again, everyone, and that wraps it up. Have a great rest of your day.